Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is second smallest number and it is a medium level problem. So the problem says that we have to find the second smallest number with the given sum of digits equals to s and the number of digits equals to d. Right. So this is our question. Problem statement is very small. So let us directly have a look at the example. So if this is the example, then we have our answer as 178, and if you observe, then the smallest number would be 169, I guess. So this is, so this is 16, right? The sum is 16 here. The sum of all the digits means 1 plus 6 plus 9, and that is equals to 16. Similarly, the next number, just next number will be 178. Now, how do we solve this problem? So this problem is particularly like observation from one point, and to that point you will have to apply some brain to reach up to that point. So actually we can divide the problem into two halves. The first task that we have is find the smallest number, right? Find the smallest number such that the sum is s and the number of digits is d, right? So this is the first task. It's just some implementation thing, right? And the second thing is to find the second smallest number. From the smallest number, we have to find the second smallest number. So this part is purely observation. You can just write down a few test cases and you can just observe what is the relation between the smallest and the second smallest number, right? So first, let us quickly discuss how we will form the smallest number. So for example, if I have uh, some digits like this, right? So the idea is that we can initialize all digits with initially 9, right? If you have initialized all digits with 9, now the total sum here would be 9 into 4, that is 36, right? If I want to form any sum less than 36, right, and I want the number to be smaller, it is always optimal to reduce the leftmost digit first, right, or the digits that has the highest place value, right? So this particular digit has the highest place value, then after then this digit will come, then this digit, and this is the units place digit, so it will have the smallest place value, right? So it's always optimal to reduce the digit which has the highest place value first. Now, reducing the digit also has a constraint that for the first digit, you can only reduce it up to 1, or you can subtract 8 from it. For the rest of the digits, you can make them all 0, and you can subtract 9 from them. You can say it in any way, right? So this is the only constraint we have, and by now you must have understood why we have only these constraints, because if we cannot make this particular digit equals to 0, otherwise it would not be like the same number of digits will not be there in our final answer, right? So we want the first digit to be at least 1 and the other digits can be 0 as well, right? So this is the constraint that we have. So now if we know our current sum initially is 36, and for example I want to make it let's say 20, right? So it is very easier for me to form. So for example, my current sum is 36, I want to make it 20. The current difference is 36 minus 20 is 16, right? I want to reduce the sum by 16. So for the first digit I can reduce it by 8, so I'll reduce it by 8. So now the number would look something like this, right? So 36 minus 8 is 36 minus 8 is 28, right? Now my current sum is 28 and I want to make it 20. So I will have to subtract 8 from it. When I want to subtract 8, I can subtract 9 from the second digit. So I'll subtract 8 and it will become 1199. So now you see the total sum will be equals to 20, and we have found the smallest number such that the total sum is equals to 20. So all we have to do is we have to take the digits from starting from the left, or the place which are the digit which has the highest place value, right? And we have to keep on moving to the smallest place value digits, just remembering that for the first digit we can only subtract 8, and for the remaining digits we can subtract 9, right? So we have to form our smallest number like this. Now once we have our smallest number, how do we find the second smallest number? So this is our second task, right? So from 169 you want to form the second smallest number. Now one thing is very obvious to us, that we would not want to change the digits from the left, we would always want to change the digits from the right now, right? Since we don't want our number to change much, we would always want our digits to change from the right. right? Earlier we were reducing from the left, now we will be increasing from the right. The goal is same in both the cases, that we want the smallest number possible. So if you start increasing the numbers from the right, you will observe that if you add 9 to it, like in this case, if you add 9 to it, the answer would be 178, and the sum of the digits will still be the same. So if you take these two digits and these two digits here, so here the sum was 9 plus 6, that is 15, and here the sum is 8 plus 7, that is 15, right? If you add 9 to it, the sum of the digits will remain same. Now what happens, let us discuss some other cases, what will happen in those cases, right? So one thing when you observe while adding 9 was, adding 9 to like two digits, when there are two digits like this, whenever we add 9, you will always observe that this particular digit gets decreased by 1 and this particular digit gets increased by 1, right? Whenever you add 9 to any number, any two digit number, right? So we will have to discuss certain cases when this particular digit is equals to 0 and this particular digit is equals to 9, right? I'm just trying to give you the approach kind of thing, the way like you can think of this particular problem. First of all, you just observe that I was able to add 9 to make this particular number into a different number which is just after it, which is the smallest number possible, such that the sum remains same, right? This was our first observation. Now the second observation is, whenever I am adding 9 to such a number, all that is happening is that the right digit is getting decreased by 1 and the left digit is getting increased by 1, right? So we have discussed this till now, we have thought of this till now. Now what happens when this digit is already 0, I cannot decrease it, and what happens when this digit is already 1 and I cannot increase it, right? These are the two cases that we have to deal with. So now we will now let us just talk about these cases. So discussing about this particular case, let us take any number, let's say 1999, right? So in this case, what is happening is, if I take the rightmost two digits, you will observe that this particular digit is 9, so I cannot increase it further, right? So let us see what happens in this case. Now the total sum here is 27, 28, right? 28. Now one thing is for sure, that this particular digit will be 2, right? After all I do, this particular digit has to be 2, because even if I add 1, this will go into 2000 something, right? So the next greater number should be something in the 2000 series, right? So I have fixed the first digit. Now I have to form the remaining sum 26 from 3 digits. So how can I form 26 from 3 digits? If you observe, then a way would be something like this. So I can write 8 here and 9 here and 9 here. So the sum here would be 26, and this is 2. 2 plus 26 is 28. So I have found a way such that it is just the next greater number, such that the whole sum is still the same, right? So till here it is pure observation. We have done nothing to deduce any conclusion or anything. We are just trying to observe what happens in different cases. So in this particular case, I was able to observe that even if I add 1 to it, I'll have to move to the 2000 series. So like the first digit was for sure has to be 2. Now talking about the remaining digits, now the problem was simply reduced to, I want to form 26 with 3 digits, right? So using the same technique, I use 3 digits like this, and the current sum was 27, right? So I can reduce 1 from here and I can form 899. So I have written that particular number. So I see that whenever the left digit is 1, that left digit is 9, this particular scenario happens. Now if you observe this thing, as long like if we start from this particular place, the left digit was 9. So what we could have done is, we could have shifted one place to the left, right? Now this particular digit is again 9. So we could have shifted one more place. Now this particular digit is 1 now. So what we can do is, what we were applying to there, we can apply here, right? We can like decrease the right digit by 1 and increase the left digit by 1. So if you observe carefully, this is what exactly happened here, right? Now this, I'm telling you, this is just observation and we are just trying to guess what can be the answer. So in this case, we have observed that like we can move further to the left whenever the left digit is 9, right? Now similarly, what happens when the right digit is 0? What happens when the right digit is 0? So let's say I have 0 here, I have 0 here, I have 1 here, I have 1 here, right? So I want to make the sum of digits 2 and I want to make the number of digits equals to 4, right? So this is what I have right now. So since I cannot do the operation here, I cannot do the operation here. In both of the cases, right digit is 0, I cannot decrease it. But when I find that I can decrease this number, can I use the same analogy that I used in this particular case? I'll try to use it. So what happens is I increase the left digit by 1 and decrease the right digit by 1. So I have this particular answer, right? Is this just the next number? Yes, it is just the next number after 1100 such that the sum is 2 and number of digits is 4, right? And you can even verify it. There is no other way you can form a number greater than 1100 such that the sum of the digits is 2. If you want to make the sum 2, either you have to use a 2 somewhere or you have to use a pair of 1 1 somewhere, right? You have already used a pair of 1 1 here. There is no sense of writing it like this because it would definitely be smaller, smaller than this number, right? So the only way that we have left is we can use a 2 here. At what position can we use 2 here, right? So the only place you can use 2 is this place, because if you use here it will have to be 0 0 0, right? This is not a 4 digit number. The only place left is this, right? So like while I'm explaining, I'm asking several questions. Like these are the questions that should come to your mind while thinking of the solution, right? That this is possible or not, this is possible or not, this is possible or not, because in this particular question we are just exploring the possibilities. That is all we have to do. This question is pure observation, right? So the only thing that you could have done is let place a 2 here. So again the same thing is happening here. Whenever there is a rightmost digit is 0, then we have to shift one base to the left and again check that the right digit is 0 or not. Then again we have to shift to the one position left, right? So we have formed a condition that we have to take two digits, right? A pair of 2 digits, so starting from the right, such that the left digit is not 9 and the right digit is not 0, right? Whenever this condition is satisfied, what we do is we increment the left digit and decrement the right digit, right? And if this condition is not satisfied, we just keep on moving down to the left. Now the last question of this particular problem: what happens if you have found no digit? For example, if the sum was something like this, now the value of the sum is 1 and the number of digits are 3. So in this particular case, there is no pair such that the left digit is not equal to 9 and the right digit is not equal to 0, because the right digit, this will be 0, this will be 0, and there is no left digit to this particular one, right? So you will observe there exists no answer in this case. You cannot form a number of 3 digits such that it is greater than 100 and the sum of digits is 1, right? You will find no such case. Similarly for 9, if you have like this, there is no pair such that the left digit is not equals to 9, right? Even if you took multiple lines, in this particular case the total sum is 36, right? So if I want to form a number such that the sum of the digits is greater than 36 and the number of digits is 4, I cannot form it. And you can observe it from here also, that this is the maximum number you can form. You can definitely not form a number greater than this, right? So we have discussed like various questions. Like this particular problem is particularly observation, and you can observe this while asking questions to yourself that how can we form the answer. So I hope like this solution was clear to you. I'll just quickly go through the final solution. So what we have to do is we have to first of all form the smallest number that is possible, and we can do that by initializing all the digits first to 1, and then starting from the left we have to decrement the digits or reduce the digits. The leftmost digit can be reduced by 8 at max and the remaining digits can be reduced by 9, right? After finding the smallest number, how do we find the second smallest number? What we will do is we'll start from the right and we will form the pair of 2's, and we will keep forming it until we find a scenario where the left digit is not equal to 9 and the right digit is not equal to 0. As soon as we find such a pair, what we do is we just increment the left digit and decrement the right digit. If we don't find a pair, we keep on moving to the left and try to find the next pair. And if we don't find the pair in the whole array of digits, then we are sure that we cannot form an answer for this particular case, right? So now let us have a look at the code, final code now. So in this particular code, what I've done is I've initialized a vector int of numbers, and the size is the number of digits, and all of them are initialized to 9. So I just initialize my current sum equals to 9 into d, right? Because there are d number of digits and 9 is the value of each digit. Now I just find what is the value that I want to reduce from the leftmost element. So I'm taking the leftmost element separately. So I just do current sum minus s comma 8 and I take the minimum of them. Now if k is a k value of k is less than 0, that means current sum minus s is less than 0, and that in turn means that current sum is less than s. That means I cannot form my answer from this particular case in any of the cases, right? If the current sum is itself less than s, then I cannot form the answer. I can only form the answer when the current sum is greater than the required sum. Now I just subtract k from current sum and I just subtract that value from the leftmost digit. Now for the remaining digits, I just do the same thing. It's just that instead of taking 8, I have taken 9 here. So similarly, again here also, if k is less than 0, that means the current sum is less than the required sum, then I just can return -1 here. So at the end, this after all this is completed, I form the smallest number in the number array. What I can do is I can just start a for loop or a while loop starting from the rightmost position or the index 0 and going to the left, and I just check this simple condition that first of all index should has to be less than d minus 1, and this particular condition has to be satisfied that either the current index is 0 or the index plus 1th element is equal to 9. That means I don't have to take this pair and I just increment the value of index. As soon as I get out of this loop, if the value of index is equal to d minus 1, that means I have not found any pair and I can just return -1. Otherwise, I can decrement the current index, I can increment the next index, and I can just create a string answer in which I'll store each of the characters or each of the digits of the number array or the number vector. So I just convert each of them into string and concatenate into my answer, and at the end I can just return my answer. So this was the solution of today's problem of the day, second smallest number. And like as I've already explained, this problem is purely observation. That is why I tried to explain it in a way such that it is easier for you to understand the thought process that goes behind these kind of questions. Right? Not only these questions, each and every question should have the same thought process. You should keep asking yourself certain questions about the possibilities of the answers. Right, so this was it for today's video. I hope you guys were able to understand the solution. If you guys did, then you can show your appreciation by dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and if you don't like the content later, you can always unsubscribe. So till the next video drops, keep coding, stay safe, bye bye.